Morning students. We were discussing about the component parts of a railway system, and today we are going to discuss a new topic or new concept in railway engineering, that is coning of wheels. Okay, so in this figure it is clear that this is the wheel, and the wheels are moving on the rail. This is rail. You have studied the different types of rail sections. Okay, so the wheels are touching on the rails, and in this figure it is clear that the surface of the wheels are made in cone shape. Okay, this is cone shape, that is the slope is 1 in 20. Okay, the wheels are made in a cone shape at an inclination of 1 in 20, and the same slope is provided in the rails also. The rails are also provided in a slope that is 1 in 20. The same slope is that of wheels. Okay, that is what is known as coning of wheels. That is, wheels are provided in the shape of a cone, and that inclination is 1 in 20. Since the wheels are provided in the cone shape, the same slope is given for the rails also. Okay, so that is known as coning of wheels. So why we are providing this type of cone section, that we can discuss. So in a railway track there will be straight portion and there will be curved portion. Okay, so we can look through how this coning works on a straight track. That is, while the train is moving on a straight track, how the coning will help. Okay, so for smooth riding, track should not touch the flange. In this figure it is the flange. Here it is marked, it is flange of wheel. Okay, so in order to have a smooth riding, the rails should not touch the flange. If it touch the flange portion, the riding will not be smooth, there will be some jerk. Okay, so in order to have a smooth riding, it should not touch the flange. Okay, so for that smooth riding, the track should touch the center of the wheel, and this is ensured by coning of wheels. So in the case of straight track, the coning helps in order to touch the center of the wheel. By providing coning of wheels in a straight path, the track can touch the center. It cannot touch the flange. So by this the coning helps for a straight track. Okay, that is the case of straight track. Okay, that is, for smooth ride, the track should not touch the flange. So this is possible by providing cone shape. Next we can look through how it's work on a curved track. In the case of curved track, the outer wheel have to cover greater distance than the inner wheel due to centrifugal force. This principle you have studied in your transportation engineering, highway engineering. Okay, that is, in order to counteract the centrifugal force, the outer wheel have to cover greater distance than the inner wheel. So due to coning of wheels, diameter of the wheel increases over the outer rail and decreases over the inner rail. Okay, that is, in the case of curved track, due to coning of wheels, diameter of the wheel increases. This is the outer rail, this is the inner rail. So in the case of outer rail, the diameter of the wheel will be high. In the case of inner rail, the diameter of the wheel will be small. Okay, this is clear in this figure. That is, this is a curved portion, this is the outer rail. So in the case of outer rail, the diameter of the wheel will be high. The highest diameter of the wheel is touching on the outer wheel, and this is the inner wheel. In inner wheel, the smallest diameter of the wheel touches. Okay, so that is the mechanism how coning works on a curved track. In the case of curved track, the diameter, due to coning of wheels, diameter of wheel increases over the outer rail. That is, the diameter of the wheel increases, that is, the highest diameter touches the outer rail, and the decreases over the inner rail. It decreases over the inner rail. Okay, so this phenomenon I will explain through a video. Okay, so this is the video which explains coning of wheels. Okay, by seeing this video you will be clear about coning of wheel, that is, how coning of wheel works on a straight path and on a curved path. Okay, So this is the curved portion. The outer diameter will be high, outer rail and inner rail. So this is the wheel. It is provided in the case of cone shape. The lower part is rail, and if it is provided in straight without providing a cone, that will occur, that is failure will occur. So for that the wheels are also provided a slope of 1 in 20. Okay. So this is how the wheels are moving on a track. So while moving in the curved portion, the outer rail covers the bigger diameter and the smaller lower diameter, and in the next section the wheel changes, that is the outer on the outer rail, then other wheel will comes on the outer rail, so its bigger diameter will touches the outer rail. Like that, when curved portion changes, when the direction of the curve changes, the wheels are also changing its diameter, like that. So this is the coning of wheel on a straight path, in a straight track. In the case of straight track, it provides in order to touch the center part, and when it reaches on a curved path, on the outer rail the bigger diameter touches. It is clear from this figure, that is on the outer rail the bigger diameter of the wheel touches on the outer rail, and next the direction changes. So in that case, this another the diameter of the next wheel will touch the outer rail. Okay. That is, when changing the direction, the wheels are changing its outer and inner diameter, like this. That is, outer rail touches the bigger diameter portion of the wheel, and the inner rail touches the lower diameter portion of the wheel. So this is what is known as coning of wheel. Okay. Next, what are the needs of coning of wheels? Why we are providing coning of wheels on a railway track? First, to reduce the lateral movement of the axle. Second one, to reduce the contact between flange and inner side of the rail. Okay. By providing coning of wheel, the center portion will touch the track. Third one, smooth flow of the train on track is made possible because of coning of wheel. Okay. These are the needs of coning of wheels. Next, disadvantages. First one, due to centrifugal force, the horizontal components tends to turn out and the rail has widening tendency. Okay, that is, in the horizontal curve, the outer portion has to increase. So in order to provide this bigger coverage on the outer rail, we are providing coning of wheels. Second one, if no base plate used under voids, if we are not using base plate, the sleeper under the edge of the rails are damaged. The sleeper will get damaged. That is the next disadvantage of this coning. And last one, here the pressure on the outer rail is more. Okay, if we are providing coning, the pressure on the outer rail will be more than the inner rail. So this will result in wear and tear of the outer rail. Okay, so these are the disadvantages of coning of wheels. So this is about the phenomenon coning of wheels. You read the textbook. Okay, thank you.